This video is to demonstrate how to set up large machinery simulation model in scSTREAM. First, let's open preprocessor and import CAD data. When preprocessor is launched, initial wizard will appear. Let's set project name and working folder. Then enable import CAD data. Specify CAD data to import. The CAD data I am going to import is saved as parse.rate file format, but scSTREAM supports most of the CAD data format. Click Finish to import CAD data and close Initial Wizard. CAD data import is completed. You can see that the number of parts in this CAD data is over 1200. Go to Edit Part Deletion to open Part Deletion dialog. For this kind of complex geometry, there are so many parts. We can delete small parts by specifying part size or volume. For this demonstration, I do not delete any parts and simulate as it is imported, but I would like to let you know that there is a capability to do so. Next step is to set computational domain. Double-click domain cuboid from left tree. Click Calculate Part Region to fit the domain to the coordinate of the geometry. To solve airflow around the machinery, enable Extend Surroundings and input values. Click Preview and confirm the computational domain. Next step is to set material property to all parts. In this demonstration, I assume that most of the parts are made from stainless steel, so I will set all the parts as stainless steel by selecting all the parts using rubber box selection. It is useful to use Change Part Setting Together menu to set part conditions at once. I am going to modify attribute and select stainless steel. Then I am going to change the material property to polycarbonate resin for some of the selected parts. Next step is to set heat source to 3 motors. Let's locate motors by hiding enclosures. You can find 3 motors in the geometry. If you double-click the part, you can set heat source individually. Let's set the heat source for all the motors. Next step is to set boundary conditions. Open Condition Wizard and move to Flow Boundary. For all sides of the domain, set Fixed Total Pressure condition. For top surface of the domain, set Natural Outflow condition. Bottom face is assumed to be floor, and no slip wall will be set by default. We are ready to create a mesh now. Open Mesh dialog and input the standard size and threshold length and click Gridding to confirm the size of the mesh. Then click Meshing to discretize to elements. Meshing finished in just over 8 seconds, and the number of elements is over 26 million, which is written in the bottom of this dialog. In scSTREAM, there is a technique to locally define the mesh by creating mesh blocks inside of the domain. Right-click on the root block and select Create Block. Define the size of the block by referring parts. Extend the domain to have some transition region away from the referred parts. And input the mesh parameters. Create 3 more blocks inside of the second block to have finer mesh around the motors. Then, click Gridding and Meshing. This time, the number of elements is about 34 million, and meshing took about 8 seconds. After the meshing is completed, let's check the mesh. From Mesh, showing mesh cross-section, you can visualize the mesh cross-section. You can select axis and move the slider to adjust the location of cross-section. Also, in parts table, you can see the volume of the original part, volume of the meshed parts, and the ratio. Now, all the setup in preprocessor is completed. So let's move to solver by clicking solver icon. Solver monitor was launched, and the simulation input file was loaded automatically. Click Execute to run the simulation. For your reference, the simulation takes 40 minutes using 8 parallels. Simulation completed. Now let's visualize the result in post-processor. Click Post icon to open the post-processor, and the result file will be loaded automatically. Since the simulation is relatively large, it will take some time to load the data. Loading data is completed, and now you can visualize the result. For example, you can see the temperature by showing temperature on surface. You can adjust the range of the temperature color bar. Also, you can show the cross-section velocity in plane. You can adjust the parameters to show vectors to easily see the flow field. There are many options to visualize results in post-processor. Let me show you some examples here. With this, I will conclude my demonstration. Thank you for your attention.